Hey everyone! In this video we will be briefly reviewing lesson 2 in terms of how do we do our analysis in software. So lesson 2 was focused on doing ANOVA tables, contrast, multiple comparisons, and sample size / power calculations. And so we're going to be focusing on how to do this in Rstudio. So in lesson 2A we had the highway paint example, where our goal was to determine if there's a difference between the two means. The first thing I showed you guys with this problem was this strip chart right here, and so I provided some code. So let's first let me first change this to something that might look a little bit better when you're watching on the video. So we're going to grab our data. I gotta remember to make sure I'm in the right directory. I'm not, so I'm gonna go to Session, Set Directory, choose Directory. This is in so set my directory. Now I can run it. I always want to check what my data looks like, and that looks like our data. Now to do a strip chart, we're going to run this code. And boom. So we're saying reflectivity is our Y, and we're going to group by our paint. Now this is allowing us to tell us what data set. So if we look at here, we loaded our data into what we call paint. And so another way we could do this is strip chart paint data $reflect strip chart paint data $paint and not have this here. But I like doing it this way preferably. Vertical equals true. If this was false, you would get this way, so your paints are on your Y and your reflectivity is on your X. The reason this didn't change is because I have the X label as for true. Then let's rerun this. Then we wanted to add points, and so I manually put in the mean points, and then this line is going to add our red stars. Our PCH is making it a star, that's what's making it red, and then we also are adding our AB line, which is the mean, the overall mean of these paints here. Typically, you also want to try and add a legend and a title. But now let's get back to the real goal of lesson A, which was to run this ANOVA analysis on our highway and get this result right here. So in order to do this, one way is to run here. So our Y and our X, Y is here, X is on the other side. And what this is going to give you is this. To make it look like our results in our homework, we're going to go summary of paint, and here is our ANOVA table. Another way you could have written this is this code right here. You'll see it's going to give us the same thing. Awesome. Now, that concluded our lesson 2A, where we were really focused on just getting this ANOVA. In lesson 2B, we introduced a new example called the bologna texture example, where our goal was to compare and see if there was a difference between these 12 mixtures. Remember, these mixtures where the combination blends. So again, we've got to read in our new data, and we want to view it. So we just want to look at it. Okay, that looks right. So let's go here. And let's run this ANOVA table. And I'm going to tell you right now, this is going to be incorrect. And let's look at it. And the reason it's incorrect is because look at our mix. We have a degree of freedom of 1. But we know from our lesson that our degrees of freedom for treatment should be T minus 1. So in this case, it should be 11. And so what happened in R, and it's harder to spot in R than JMP because JMP has triangles and histograms indicating it. But pretty much what happened was R read this variable mix as a continuous number, 1 through 12. So it read it as a number and not as a factor. So in order to fix that, we're going to run this code, which is going to make this as a character and a factor. Then we're going to run this line and get that. I don't know why I have this line, to be honest, but it wouldn't make a difference. See, it doesn't make a difference. For some reason, I can't remember the reason right now, I subtracted the means from the texture, but no worries. So, but in lesson 2B, we were focused on constraints. And in order to do a constraint that is similar to jump and relatively easy to connect with our notes, we need to install this library. So I've already installed the library, but if you forgot how to, you're going to go up to Tools, Install Package. You're going to type in multi-com, press Install, and then it will install. And then you have to run library, because each time we open up our R, whether the package is installed already or not, you need to run this library every time. Okay? Now what we're going to do next is run this function, which is coming from this multi-comp. Now notice we have this bool ANOVA, and so we saved our result, and now we're going to use it. And how we're going to do our contrast here is through this right here. Now note, this mix is related to this mix. So if we had a different problem and our factor, our treatment was named bubblegum, then you would need to put bubblegum here. And then we're going to be doing a two-sided test. If we wanted to do one-sided, then you would change this to greater or less than. How we can figure out all those little details is going GLHT, parentheses, enter, and we'll get all the help we need right here. Okay? So we're going to Control, copy, paste, and run this, and then we'll get our result here. Now again, this one right here will match our jump result, because when you do jump like we showed it in the notes, jump automatically is going to do this type of division. If you watch the jump video, it'll make sense as I click into it. But let's say we didn't want to divide by 6 and we just wanted to run this contrast, and that's what that's doing. Again, as long as your contrasts sum up to 1, you'll be good. Now, in lesson 2C, rather than worrying about a specific individual hypothesis, we were worried about multiple comparisons. And how we can do that is through Tukey's. And this is one way that you can do Tukey's in R, which is using the package that we installed, so that's kind of why I like it. And we get a summary, and it's going to take a little bit. Give it a second. And then we get all of these outcomes that we saw in our notes. Another way we could do this is by plotting this result. And what this plot's going to give us, give it a second. Are the confidence intervals. And if they cross this 0, that means there isn't a difference between those two treatments. This is how you would do it for Fisher's test. Now, our next step is to talk about lesson 2D, where we are talking about power and sample. In our notes, we were focused on looking at it through jump, but here we're going to show you how to do it through R. So we're going to input the way to make it look similar to our notes and how I talked about it in class, I have this group means variable. Then we're putting in our standard deviation. Again, you're going to either get this from a pilot study or lit review or doing that heuristic rule. Then we're going to use power ANOVA.test. This right here, groups, is going to get the number of groups. So length of group means is going to output 4 because we have 1, 2, 3, 4. We want to find the sample size in example 1, and so we're going to leave that as null. Now we're going to have between.variance, which is just going to be the variance of the group means. Now Jump's doing this in the background by having us input the values like we did. R is making us do it this way. Then this with invariance is going to be your standard deviation squared, because again we're dealing with variance. And then we have power of 0.9. We're going to control, copy, paste, run, and we're going to see we get these same answers. Now, let's say we wanted to find power. And so in our second example, we said our replicates per group were 9. Again, in R, this is reps per group. And then we'll leave power as null. Another example that I want to talk about, we'll just go control copy, control paste, and we'll call it example 2a. Was if, let's say, I want to change this up. We were trying to find a difference between the two groups that's maybe a difference of 20 rather than 15. And maybe we have 5 groups. These 3 groups would be in the middle, because again, that's the hardest to find. We'd have a standard deviation of 7. You could change that if you wanted, but I'm just trying to give you guys another example. Paste, and you'd get 5.3.